to welcome to the International Training Program Plan 2025. Practical Learning in Agriculture and Allied Next Generation Technique, also known as Plan 2025, being held from 18 to 24th December 2025. Plan 2025 is not just a training program, it is a movement towards transformative agriculture. Over the next week, participants will immerse themselves in cutting edge modules on digital agriculture tools, entrepreneurship in agribusiness, sustainable farming practices, integrated horticulture systems, climate resilience strategies, Global Bloom Initiative, inclusive growth modules, academic excellence sessions. Our vision of Plan 2025 is to lead a transformative movement in agriculture and allied sciences through ethical research, innovative technologies, and sustainable entrepreneurship that uplifts communities and ensures global food and resource security. Our mission of Plan 2025 is to empower researchers, entrepreneurs, and farmers by fostering academic integrity, advancing agri-tech solutions, and promoting sustainable practices in seed production, livestock, exotic crops, and resource management, driving inclusive growth and international competitiveness. The key objectives of Plan 2025 is first is to provide participants with digital agriculture tools including drones, AI, IoT, and mobile applications to enhance precision farming and decision making. Second objective is foster innovative thinking in agribusiness by guiding participants to design, launch, and scale sustainable and profitable agri enterprises. Third objective is to promote sustainable farming practices that conserve resources, improve soil health, and support long-term ecological balance. Fourth is to integrate horticulture systems across vegetables, fruits, and floriculture to diversify farm income and enhance agroecosystem resilience. Encourage innovation and problem solving through hands-on learning, case studies, and exposure to emerging agricultural technologies. Enhance academic writing and publishing skills to empower participants to contribute to educational discourse and circulate impactful findings. Build a collaborative learning environment that connects farmers, researchers, entrepreneurs, and policymakers for holistic agriculture development. Now, moving forward, I'm going to introduce our today's guest of honor, eminent speaker, resource person, Dr. Rajiv Kumar. He is an agronomist, skilled researcher, and respected academician. He is an agronomist, skilled researcher, and respected academic leader currently serving as professor in the Department of Agronomy at GB Plant University. GB Plant University of Agriculture and Technology, Pantnagar, Uttarakhand. He also holds the prestigious position of Director Research, School of Nanotechnology in Agriculture, where he leads innovative work at the intersection of advanced science and sustainable farming. With over 2 decades of experience in teaching, research, and extension, Dr. Kumar has made remarkable contributions to the fields of natural farming, nutrient management, soil fertility, and the application of nanotechnology in sustainable agriculture. His work is characterized by a unique integration of traditional agricultural wisdom, including principles from Briksha Ayurveda, with cutting edge nanotechnological innovations. This interdisciplinary approach has enabled the development of eco-friendly, resource-efficient, and high-yielding cropping systems suited to modern agricultural challenges. Dr. Kumar has guided numerous MSc and PhD scholars nurturing the next generation of agricultural scientists. His academic output, including more than 20 research papers, review articles, and technical bullets published in reputed national and international journals. His research has significantly advanced scientific understanding in areas such as nanofertilizers, dynamic plant-soil microbe interactions, and sustainable nutrient management strategies. A committed member of all the scientific community, Dr. Kumar is a life member of several professional societies, including the Indian Society of Agronomy and the Indian Society of Soil Science. He has represented Pantnagar University at various national and international scientific platforms, contributing to policy decisions, collaborative research, and global knowledge exchange. Through his leadership, vision, and interdisciplinary research, Dr. Rajiv Kumar continues to champion the scientific validation and large-scale adoption of nanotechnology-based and natural farming systems, strengthening the foundation of resilient and sustainable agriculture in India. Today, Dr. Rajiv Kumar joins the Plant 2025 International Training Program as an eminent speaker. He will deliver an insightful lecture on nanotechnology applications in agriculture, highlighting transformative innovations that are reshaping nutrient delivery, crop productivity, and sustainability farming practices. I'm going to hand over my session to the Dr. Rajiv Kumar. Kindly, sir, share your views about nanotechnology topic.
Thank you, Manjot. Thanks for your nice introduction. And before I start my talk on nanotechnology, nanofertilizer, I wish to thanks the organizer of Plant 2025. A very important topic assigned to me, that is to speak scientific dimension of nanofertilizer and its application in agriculture. So first, before I start, I just want to know, am I audible to all?
Yes,
Am
sir,
I audible?
yes, sir, you are audible.
And one more thing, who is my audience? What level they are knowing about that particular science?
सर ऑडियंस में सभी मतलब बीएससी एमएससी पीएचडी स्कॉलर्स केवी के साइंटिस्ट सभी हैं इसमें
Okay,
और कुछ
okay,
फार्मर भी हैं अपने साउथ इंडियन
okay.
जी
Thank
सर
you. Thank you, Gurpreet ji. So, as we know that each and every organism require energy for their daily routine work. Either plant or human or animal or microbes or anything else, they require to energy from for their well-being. Similarly, plant require energy, and that is getting from the plant nutrients. And we, as we all are knowing that there are 16 or 17 plant nutrients, which is coming under essential nutrient for plant. With the absence of these plant nutrients, plant cannot complete their life cycle. And these nutrients are basically carbon, hydrogen, oxygen, nitrogen, phosphorus, potash, calcium, magnesium, sulfur, iron, zinc, boron, manganese, copper, sometimes nickel and cobalt. So these nutrients are very much essential for the plant. And in the absence of any one nutrient, plant cannot complete their life cycle. So among these nutrients, they are further categorized as macronutrient and micronutrients. And macronutrient further categorized into two parts, primary nutrients and secondary nutrients. Why I am talking about that? If you are talking about primary nutrient is much more in use as compared to secondary nutrient and micronutrients. And farmers are mostly taking care of primary nutrient, and among the primary nutrients, nitrogen, phosphorus, and potash. Farmers are most of the time taking pain for the nitrogen, and they are just omitting the phosphorus and potash. So today we will discuss about the all the nutrients required for the plants, and these nutrient sources are known as fertilizers. So if you see the nutrient use efficiency, so in case of primary nutrients, I mean to say nitrogen, phosphorus, and potash, nitrogen merely 30 to 40% nitrogen use efficiency is there. If you go for the phosphorus, it is around 10 to 20%. And if you go for potassium, again 50 to 70%. Means the nutrient use efficiency of nitrogen, phosphorus, and potash is far behind the you can achieve. Similarly, if you talk about the micronutrient use efficiency, it is rarely 1 to 5%. And what happened if you see the another facet of this nutrient use efficiency? If you are applying 100 kilogram of nitrogen, only 30 kilogram of nitrogen is useful for plant. Remaining 70 kilogram of nitrogen goes waste, either in form of denitrification or volatilization or leaching losses. So It is not only waste, it is further dangerous to the
Hello,
human and animal health. For
Rajesh
example,
sir.
yeah, hello.
Sorry to interrupt you, but it seems the slides are not displaying properly. Could you
That's why
please
I am
try
saying
again?
you just share it. There is some problem. Actually, I'm not changed the slide still. Hello.
Okay, sir.
This is my
Gurpreet sir.
first slide.
जी सर प्लीज आप एक बार स्लाइड चेंज करके देखिए हो रही है स्लाइड चेंज
Wait. Is it visible? I changed the slide.
नहीं सर चेंज नहीं हो रही स्लाइड
Please share from your own side. Okay. Is it okay?
जी सर मैं देखता हूँ
Okay, sir.
I'm just going to stop share from my side.
ओके सर एक मिनट
So,
सर आप पीपीटी शेयर कर दीजिए ईमेल दोबारा से
फिर दोबारा से कर दें?
जी
अभी
वो
तो
लिंक आ गया था पीपीटी नहीं आई प्रॉपर
okay. Wait for sec.
टेक्निकल इशू होगा
हाँ, कुछ भी हो सकता है। आजकल तो कुछ पता नहीं चलता ना। share.
Sir, please click on the screen button. There is a screen button on that.
Wait, I'm just sharing my PPT, okay?
Okay, sir.
सर आप पीपीटी स्टार्ट करके ना यहाँ पे नीचे शेयर लिखा होगा ग्रीन एरो है ना जहाँ लिखा हुआ लगा हो नीचे
हाँ,
नीचे ग्रीन एरो है एक शेयर का आप वहां पे क्लिक कर दीजिए पीपीटी ऑन करके
नहीं हो रहा है हमारे यहाँ से भाई। मैंने फिर से दोबारा से PPT आपको शेयर कर दिया है। आपको मिल गई?
नहीं सर
क्या चक्कर है? ओके, एक बार मैं फिर से ट्राई करता हूँ, ठीक है? अभी विजुअल है क्या?
ये आप नेक्स्ट करके देखना सर शेयर करना आप नीचे हाँ
अब
अभी
दिख
सही
रहा
है
है
सर
अभी?
हो
हाँ,
गया सही
हो गया?
Yes, sir. Visible.
ओके। So what I was talking that micronutrient use efficiency is 1 to 5%. And for example, if you are applying 100 kg of nitrogen, only 30 kg of nitrogen is used by the crop, and remaining 70% get vanish in the system, and further it aggravates the health issues among the humans, animals, and plant too. So, what would be the options? If you think about the fertilizer, history of fertilizer, before I go for the nano fertilizer, history of fertilizer is started with the use of guano, means bird excreta, phosphorus. The first fertilizer used for the plant nutrition is the phosphorus, which was taken from the sea areas, collected from the sea areas, and supplied to the plant, applied to the plant for their nourishment. Then further goes on, invention of urea were done, and urea rule across the world, and we are third maximum utilization of urea in this world. India is the in third position to utilize nitrogenous fertilizers. Similarly, in case of phosphorus and potassium, phosphorus, we are around 80% we are importer of phosphorus, and we are importing phosphorus in different countries. You can say Russia, Canada, Morocco, and similarly 100% of the potassium we are importing from the different countries. And if you see the efficiency of these three fertilizers, 30%, 20%, and 50 to 70%. Maximum import prices get waste. So what could be the options? This is the major issue and major challenge among us. What could be the option to save our foreign exchequer and on one side and save our human health on the other side? So we have only one option, and that is to increase the nutrient use efficiency in the system.
Rajiv sir, uh, the slides are not displaying
I am
properly.
not okay. I am
सर
not
नीचे ना
changing the slide.
ग्रीन बटन होगा वहां पर आपको क्लिक करना है और एंटायर स्क्रीन पर क्लिक करना है
Uh, no, I am
नीचे
not changing the slide, madam. This is my next slide. Is it visible?
यस
So I
सर
am not
अभी
changing the slide.
ओके सर ओके
I am not changing the slide. This is the just introductory slide.
ओके
Before
सर
I enter in the subject,
ओके
we
सर
need
सॉरी
to
फॉर माय
understand something.
इनकन्वीनियंस
Okay.
ओके सर
And okay, there is some miss slide has opened, no issue. So what I was saying that we need to increase the nutrient use efficiency in the system for saving our nutrient, foreign exchequer, and environment as well as human and animal health. So what would be the option? So maximum nutrient losses, maximum use of nutrient is nitrogenous fertilizer, and maximum losses of nutrient nitrogenous fertilizer nutrients. Whole of the system is running behind the increased nutrient use efficiency of nitrogen, and you will feel surprised. Urea, then neem coated urea, then super granule, then polymer coated urea, then zinc coated urea, then thiourea, then controlled release fertilizer, then slow release fertilizer. There are so many developments have developed for increasing the nitrogen use efficiency in urea. And these development, this is the advancement of nitrogen use efficiency through nanotechnology, and once intervention of nanotechnology for the development of nanofertilizer, and the major target is to increase the nutrient use efficiency of the nitrogen or any nutrients. So there are three ways to prepare nanofertilizers. Basically nanofertilizers can be is of three types. One is there is your major nutrient, you cover the nano materials with the nutrient. Second is nano internalization, your nutrient would work as the nano fertilizer. And third is your nutrient would tag with the delivery vehicle, nano delivery vehicle. So there in case of fertilizer there are three kind of nano fertilizers or nano nutrient. One is internalization of plant nutrients, the second is nano coated nutrient, third is nano delivery tag nutrients. So in last there are so many ways to prepare or formulate the nutrients, but these all the nutrient nano fertilizer formulation is categorized into two parts. One is top down approach and second is bottom up approach. In case of top down approach, you are just breaking the big material into small material, and in bottom up approach you are just assembling the small material and to make a big material up to nano size. So before I start, we must understand what is nano size. As we all are knowing that if any material having size is 1 to 100 nanometers, means if you are cutting 1 meter into 10 to power 9 times or 1 billion times, then it called nanometer. So nano size is Means if you are any material having size and its dimension is ranging between 1 to 100 nanometer, then it called nanomaterials, or if fertilizer, then nano fertilizers. Now the next question is that why it is 1 to 100 nanometers? Why not 1 to 1000 nanometer? Why not 0 to 1000 nanometer? Or why not 200 to 2000 nanometers? So actually the logic or the reason behind this categorization is that once your size is reaching to 1 nanometer, it subjected to the quantum impact. Means quantum effect started to work once your material size is 1 nanometer, and quantum impact get completed if your material size is 100 nanometer. That's why the nano size is directly or indirectly related to the influence or impact of quantum or quantum effect on the material. But in some cases, if you're talking about biological nanomaterial, it goes beyond 1000 nanometers. In some other cases, you can find it is up to 2000 nanometers. So, nano size, most of the cases is 1 to 100 nanometer, but in some cases, some special cases, it goes up to 2000 nanometers. And these nanometer, one is your quantum effect or quantum effect, you can say, and other is surface volume ratio. Means surface area increases too much. A very high surface area will develop once you are converting any material into nano form. So surface area is the very much important for the nano material, or you can say nano fertilizer. For example, if you're talking about surface area, for example, you have a single note of 100 rupees. So how many person you can give a single note of 100 rupees? Only one person. But if you have coins of 1 rupees and 100 coins of 1 rupees, then you can distribute it with the 100%. Same thing happens with the nano fertilizers or nanomaterials. Means the major quantity or major volume is safe, but you can distribute a lot of the distribution receivers will be a more and more in numbers. So before I go in detail, I would first discuss with the most remarkable nano fertilizer, which is now the days mostly discussed, most are the discussed in all the arena of agriculture, either student or scientist or policy maker or farmers or any other who are related to agriculture, and that is nano urea. There is a lot of hue and cry in our country is going through the for the nano area. Some scientists are saying it is not good for sustainable agriculture. Some scientists are saying it is good for sustainable agriculture. Or some scientists, there are so many pros and cons of nano urea we are murmuring in our system or in our society. So today I'm trying to discuss what is the exact nano urea and how it can fulfill our sustainable agriculture requirement, sustainable agriculture or sustainable health requirement. So before I go in detail, I will first want to clarify what is nano urea, and that is basically can be easily understandable that what is nano urea. And you see the figure and why it is so much, it action or it effect is too high. This figure is visible or not? Am I audible?
Yes, sir.
This figure is visible.
Yes, sir. Yes, sir.
Yes,
Okay.
sir.
So you see the formula of urea is NH2CONH2, and here is the uh, cursor is visible. you know C double bond O, C S2N and C NS2. And these one mole means, you can say for easy understanding, one molecule of urea contain weight is 60 gram. One mole, or you can say one molecule of urea contain its weight is 60 gram, and this make the molecular weight of urea is 60 gram, and out of these 60 grams 28 gram of nitrogen. And you see this figure, you see the electron type of figure is, I think you might be seeing this, and this is the number of these atoms is 6.02 into 10 to power 23, means 60 gram of 1 mole of nano urea contain atom numbers is 6.02 into 10 to power 23 atoms. And what's happened, we club the atoms within the 60 gram of urea, means 50,000 एटम्स का वन ग्रुप बना लिया, 50,000 एटम्स का दूसरा ग्रुप बना लिया, तो सेम weight of urea produce a number of nano urea molecules, means 60 gram of weight is 60 gram is fixed, but number of urea molecules increase, and I think 50,000 to 1 lakh molecules is preparing by the making nano urea the same weight of urea. And this is the basic implication where nano urea work, means the same amount of same weight of urea converted into numbers of nano urea, and each molecules are each number of nano urea work equally as your major normal urea is working. So this is the major what why I am conveying, I'm trying to convey this thing is 60 gram weight is same, but that effect or implication is too high. And this is the basic. Once you understand this figure, then you can understand the implication or essence of the nano fertilizer or nano urea development and formulations. Now another question always coming in the system, how nano urea provide the nutrition to equally provide the nutrition to the plant, where the same as compared to the urea. For example, a wheat crop require one uptake, not require 150 kg of nitrogen to produce 50 quintals of wheat yield. Means for producing 1 quintal of wheat yield, you require 3 to 4 kg of nitrogen and 7 to 8 kg of urea. Means 1 quintal of yield require 7 to 8 kg of urea. However, in case of nano urea, scientists and even companies are claiming that 20 gram or 22 gram of nitrogen is sufficient to fulfill the demand of 1 kg, 1 quintal of grain production. So how it's happened? What could be the logic behind this? Most of the question asked by the different scientists and different policy makers and different farmers level too. So I am trying to convince, I am trying to show this, what could be the possible reason of this behind this. For example, of normal nitrogen management, this is I think wrong file I uploaded. Normal nitrogen management condition, we are this is just a assumption. In case of wheat crop, 150 kg of nitrogen is required to produce, are recommended to produce maximum wheat yield in northwestern plain zone. Northwestern plain zone is started from Jammu, Punjab, Haryana, part of western Uttar Pradesh and Tarai region of Uttarakhand. And if you see that their use efficiency, it is only 45 kg. 105 kg nitrogen loss in the system, and grain content is around 100 kg for 50 quintal per hectare. So there is a difference. There is a difference. Only we supply nitrogen through urea is 45 kg and requirement is 96.5 kg, and 51 kg nitrogen balance is there if you are going for conventional urea application. And in contrast to this, and in comparison to this, nano urea application is providing a loss of 52.6 kg per hectare. In case of normal nitrogen management, it is 105 kg per hectare. But in case of nano urea management, it is 52.6 kg per hectare. So what it means you are saving a lot in sense of fertilizer production technology, in sense of currency, in sense of water impurification, in sense of environmental loss, in sense of human health loss, because almost double is providing to the crop when we are going for normal nitrogen management through urea. However, the difference is 51 kg from 51 kg of nitrogen coming from the soil if you are going for normal nitrogen management practices. In the same situation, nano urea management practices, your about 75 kg of nitrogen comes from the other sources except the nutrients. So if any system can help to provide 51 kg of nitrogen per hectare, so the same system can provide 675 kg of nitrogen per hectare, and that's why there is no issue on soil health or environmental health or human health, even in the grain health, grain yield health. By this logic, you can easily understand nano urea or normal urea, both are affecting same way to the crop and crop yield. So this I just want to convey how nano urea is formulated and how it can fulfill the demand of crop and save the losses of nitrogen from the environment. This is urea, nano urea. This is not the result of the nano urea, is the result of nanoparticles. Actually, initial days when I start the work on the nanotechnology or nano fertilizer, I started my work with the titanium dioxide. Nano titanium dioxide, I purchased the nano titanium dioxide and apply it with the foliar application were given to the wheat crop. And we find that we can reduce the dosage of fertilizer when we apply it with the nanoparticles or nanomaterials, and it is not only impact the grain yield or wheat performance, it also impact on the soil microbial population. And you can easily understand by these figures. See, fungi population increase in somewhere, bacteria population increase in somewhere, and actinomycetes population increase in somewhere. But one thing is common: if you reduce the fertilizer, conventional or chemical fertilizer doses, it increase the number of microbes around the wheat soil. Similarly, one important data we have developed in our own lab, that if you are going to utilize biological nanomaterials, then the number of microbial species or microbial diversity is too high once you are applying in the nanomaterials, and if you are applying in the biological nanomaterials. So you see there is a blue line, and blue line shows that this is the chemical fertilizer, and y-axis it is clearly mentioned the species diversity, means microbial species diversity, and in right side sample is written blue is chemical fertilizer, and red is your nano urea, and green is your biological nanoparticles. So you see if you are going to apply nano urea, it increase the species richness in the soil. And this is my own data. If you are going for giving nano urea in the soil, so your biological diversity will increase in the soil. And this also support to fulfill or to complete the balance which is generated through the excess amount of uptake of nitrogen from the soil. So it maintain the loop. By this way, soil, plant and atmosphere maintain the loop of nitrogen dynamics. So this is the one important figure my own lab, and this is the richness of the microbes which are responsible for the different kind of activities in soil microbial system. And you will feel surprised, different kind of microbes and their different kind of actions were noticed once you are going for the application of nano fertilizer or application of conventional or chemical fertilizer. Definitely, if you are going for the conventional fertilizer, your soil microbia is loaded with the disease resistant kind of microbes. Once you are going for nano fertilizer, nano urea application, more correct, nano urea application, your soil richness will be more with the decomposer type of microorganism. So by this way, it is proved that in case of nano urea application, soil organic material fulfill the demand of nitrogen which is lack or which is the getting disturbed or getting lower. So by this way, by producing or providing such kind of microorganism which help to release the nutrient from the organics, and it is proven that nano urea application of nano urea favors to the such kind of microbes in the soil. Then this is again the same thing, what kind of microbes available in what kind of situation. For example, we have already discussed that if you are applying nano urea, decomposer type of microorganism get dominant. If you are applying conventional urea, then resistant disease resistant type of microbes are developed in the soil system. So this is the result of my another experiment. Then our own nano fertilizer, this is also my work, but our other I just want to summarize what work we did in last 10 to 20 years. So our group is working in two direction. One is formulation and synthesis of nano fertilizer or nanoparticles, and their field and lab studies. So what our group and our work did, that we have developed synthesis of nano urea, nano hydroxy. These are mostly the work of my PhD and master's student. In what is written here, this is almost my PhD and master students' work. So our lab is involved in the synthesis of nano fertilizer and their field or lab study. So basically, we have synthesized nano urea, nano hydroxyapatite, nano potassium in the from biological source. We synthesize nano gypsum, nano pyrite, nano rock phosphate, and chitosan based copper nanoparticles. And at least one thesis is completed on these 7 synthesis. And further, we have synthesized a lot of things. We'll show you later. And field studies, this is our synthesis part. And the field and lab studies are, we did impact of nano TiO2 on the wheat crop, how nano zinc, nano nickel, nano chitosan, and nano silica influence the wheat seed germination, what are the impact of nano gypsum to reducing the fertilizer dosage and wheat performance, what is the impact of nano hydroxide, which was prepared by the Excel. We have prepared, our group has prepared the nano hydroxide by the Excel, and we have research work on our field and lab studies on nano urea, nano DAP, and nano potassium, and further we have worked on the plasma technology. So this is a very long, lengthy discussion, and very few. I just few slide I wish to discuss. So in next, this is our experiment. We started the first experiment in the year 2010, field experiment in the year 2010, and this is how the block, experimental block, nano fertilizer. I think this is the first of its kind in our country. We have fortunate enough that we have a block where nano fertilizer experiment conducted since 2010, and we have a site which is 16-year old subjected to the nano fertilizer application. This is fact. In case of nano fertilizer, we applied all those things in the same field, but this is a rare combination where nano fertilizer experimental block is developed by any university in the country. So this is a strength of ours. We have a very strongest site for the nano fertilizer experiment. And upper side, Mr. Satpal, who started the nano fertilizer works at Pantnagar University. And he was my master's student, and he started his thesis work in the 2010. And after that, continuously we work on the nano fertilizers. Then our first work shows that application of titanium dioxide at flowering stage, you can omit either P or K in the total fertilizer 150, 60, and 40. 150 is nitrogen, 60 is phosphorus, and 40 is potash. So if you are going to apply 0.02% of titanium dioxide, then it increase the photosynthetic ability of the crop, and we said that photosynthesis enhancer means it provides the stay green characters to the crop if it is subjected to the nanoparticle, titanium nanoparticle application. But what is exactly if you are applying nitrogen and omitting phosphorus or K both, then 0.02% concentration is good. If you are applying P or K along with here, 0.04% concentration is good. If you are applying NPK, all three, then you can go up to 0.06%. What it means that the rate of nanoparticle application is depend on how much you are providing the nutrients for the crop growth and development. And if you increase the fertilizer doses, then you can increase the nano fertilizer concentration. But if you doesn't want to increase the fertilizer doses, then you need to reduce the concentration of nanoparticles, especially in case of titanium dioxide nanoparticles. Oh, this is an stay green character means your crop will green for longer period, which I received in my own experiment. Now another experiment we did in the seed treatment, and we find that if you are treating your seed with nano gypsum at the rate of 100 ppm, then your crop would be much more better, germination would be higher, root length would be higher, and shoot length would be higher in case of gypsum at nano gypsum at the rate of 100 ppm as compared to 50 ppm gypsum and 100 ppm normal gypsum and control 2. So means once you convert your gypsum into nano gypsum, your seed germination would be good. Another experiment in our group were seed modifications. Actually, what happens, imbibition of water is the major driver for seed germination. And sometime the seed coat or seed surface resists to entry of water by crossing the seed coat. So we use the nanoparticles to increase the number of pores on seed coat for increase the entry of water inside the seed. And we used titanium dioxide nanoparticle, zinc oxide nanoparticle, chitosan nanoparticle, nickel nanoparticle, and normal seed. And we found that chitosan nanoparticle provide good modification in seed for favor to the entry of water in the seed once you are treating your seed with the chitosan nanoparticle for 4 hours. But if you increase the number of hours, your impact of the nanoparticle get reduced, and further 8 hours it further reduced. Means if you increase the imbibition, you can use nanoparticle for better seed germination. This is again my this is again another experiment in wheat. All the experiment mostly from the wheat, and all the experiment, if you see the abiotic stress, if you're going for late sown wheat, December 20, December 30 and January 30, if you are going for late sown wheat, if you're sowing the wheat in January, wheat is subjected to heat state at the time of flowering and anthesis and grain filling. And in northwestern plain zone, December and January are considered as late sown wheat, and all these kind of wheat are subjected to the heat state at the time of their reproductive growth. So to check the heat stage at the reproductive growth stage, we use different kind of nanoparticles, and we find that alginic acid and nanozeolite and nanochitosan application at anthesis stage help to reduce the impact of heat on the crop, and grain yield will be managed under heat stress condition. Once your wheat is subjected to heat stress, your grain gets shriveled, and by shriveling the grain, the test 1000 seed weight get reduced. So by the use of nanozeolite, use of nanochitosan, a simple alginic acid, your grain weight is the managed. Now another experiment of same experiment by the PhD student, we try to make the combination with the nano gypsum with the microbes, isolated microbes. And there are two situations, one is A and other is V. A situation is sterilized condition, sterilize your soil, and B is unsterilized situation. And isolated, I am not knowing the microbes name, identified microbes name, but once your microbes is tagged with the nano gypsum, your crop performance will be good. You see that this is the self-explanatory picture. In number PCNG, here is written NG, nano gypsum, and PC means isolated microbes plus nano gypsum, and isolated microbes 2 plus nano gypsum. Means nano gypsum work positively with the when it apply with the microbes, and it impact or it impact or results a good growth yield of crop once your nano gypsum applied with the microbes. This is again another our experiment from my PhD student. And one more thing, microbial diversity is also increased once you are going to apply nano material under stress condition. So this is another good important thing. Then you see wheat yield nano urea. I just want to show here, this is not my work, my group work, it is across the country work. And wheat group is divided, or wheat growing area of the country is divided into 5 or 6 zone: North Hill zone, Northwestern Plain zone, Northeastern Plain zone, Central zone, and Peninsular zone. And you see the red color and red color and blue color. And you can find in any bar, you see any bar, yellow color is your control. You can find any bar that is show the positive impact of urea, nano urea on the wheat yield across the country. It might be vary in case with 75% yan and 50% yan, or simple application of urea, but wheat yield positively influenced by the application of nano urea across the all the zone in 2 years data. In case of Pantnagar, it is again good. And one more important thing is there, the result is not due to the more number of tillers or more number of greenery when you apply nano urea in the field. It results is the more number of effective tiller, prevent crop from lodging, and prevent weed menace or weed scenario in the field if you are going for application of nano urea in the field. So this is the across the country result on nano urea along with Pantnagar. Then another, my own student, PhD student, they has published the paper, good paper on this topic. Nano urea, nano DAP, and nano potassium. Nano urea and nano DAP was procured from the IFCO, but nano potassium was produced or formulated in our own lab. And you see the figure, what's happened, this is the strip plot design, and one horizontal strip application of nitrogen in respect to nano urea were done, and another vertical strip, your DAP, phosphorus were applied through DAP and did not DAP, SSP, and nano DAP and nano potassium in other plot. Three plot, there were three plot, and we find a good result. Either you go for SSP or MOP. Nano DAP and nano potassium give good result on yield, and which are at par with normal nano urea. Here you see the N source and P and K source. P and K source were applied in vertical strip, and N source are applied in horizontal strip. N1 is the basal, N2 is skipping the basal, N2 is the skipping the basal, N3 is your basal 150%, sorry, means 50 kg as a basal, मतलब 1/3 as a basal, and 2/3 through nano urea, and fourth is 100% basal and with additional application of nano urea. And you find you can save 50% of nitrogen with the application of nano urea N3 and N4. This is again a wheat example of wheat crop. Manjeet ji, hello, am I audible?
Yes,
Hello?
sir. Yes, sir.
जब टाइम हो जाए तो मुझे बता दीजिएगा.
Okay, sir.
हाँ. So another experiment, we have a nano potassium. The nano potassium we have formulated in our synthesized or formulated in our own lab. So we prepared the potassium from the biological source, and these biological source of water hyacinth, or you can say some other sources, and we apply it in the field, that is the maize field, and 300 ppm, 600 ppm, and 900 ppm were ppm of nano K were applied, and their comparison with 300 ppm KV plus 20 kg of normal K as basal, K 40 kg. The recommendation of potash in maize crop is 40 kg. So 40 kg K without nano is basal, and 0 control K without basal. And we can find out that if you are going for applying 20 kg of potassium as a basal, 300 ppm is a good combination. 3 ppm of nano application at testing stage is the good combination. And if you're not going for applying basal, then 900 ppm would produce similar yield. So this is the impact of nanopotassium on cob. Then another important experiment we conducted, glycemic index. You know, the glycemic index is the major indicator of the sugar situation in the crop. So we choose an low glycemic index varieties, that is Bansi, Khapli wheat, Bansi, Khapli, C306 and Sonamoti. And we applied three different kind of treatment. One is control, second is liquid fertilizer, liquid nano fertilizer, you can say liquid organic nano fertilizer, and third is nano urea. And you see the impact of these. Red color means when our seed were used to sow, so red color show the glycemic index of that particular seed before sowing the experiment. But once you harvest the crop, and what would the impact of the nano on glycemic index, it is clearly visible that application of liquid organic nano produce low amount of low glycemic index, and nanourea also produce low glycemic index in case of Bansi as compared to seeds which were used to sown before. C306 followed the similar trend. Even though Khapli followed the similar trend, Sonamoti followed the similar trend. And among these four varieties, Khapli is having very low glycemic index. So means nano, these are an avenue where nano can work to reduce the glycemic index of the grain. This is another opportunity to think it. Then another work in our lab we did gas in nano state. Gas gains gas in nano state, and indirectly you can say plasma technology. What's happened? This is the plasma reactor, and we use the argon gas here for treating the seed. This is the situation how plasma developed, and by this way plasma can develop, and this is the condition where seeds were put for the plasma treatment, or you can say gas in nano state. And this is the wheat seed, and SEM image clearly vindicated. इस दोनों चित्र से आपको क्लियर दिखेगा कि जो first seed, after the seed picture, just beside the seed having big growths and required good amount of water, high amount of water for the imbibition. But once it is subjected to the plasma treatment, their growths get their surface area increase, means less amount of water would be able to penetrate the seed coat and would able to germinate the seed. So this technology would be useful in those areas where rainfall or moisture is a constant at the time of sowing. So this is the an important avenues of nanotechnology where less amount of water can be utilized for the seed germination. And this is some pictorial picture. I think I am just reaching to my end of my talk. Pictorial picture of the my own experiment. You see, here is the Sarbati C306, both are same variety. One is treated with the nano urea and other is not treated with the nano urea. And you see the impact of these. In the month of last March and April, there was the heavy rainfall with the thunderstorm, and the same crop, same variety, one get lost and other get not lost. And so nano urea help to prevent the crop from lodging. Another picture you see, this is the again same variety. The portion which is showing lodged, it is 100% NPK, and which is not lodged, it is nano urea application. So this is a very important thing, especially in case of cereal and especially more specific in case of wheat. Nano urea help to manage the lodging in wheat, which is the major problem across the northwestern plain zone. So this is another pictorial image, and this is our nano DAP experimental image. You see, this is the just aerial picture. Just I just want to convey that in these there are six strips are there, 1, 2, 3, 4, 5, 6, and you cannot assess is any difference between these strips. There is no difference visually, even though one is 50% phosphorus with application of nano DAP. And other experiment you can find nano urea is better than control. Nano urea is better than control. This is nano potassium, not nano urea. Nano potassium is also help to reduce the lodging. This is another experiment. And similarly, another experiment we have developed in the nano urea, nano potassium, and nano DAP, and we are finding a good result. Again, you see that there is no need to explain where you apply only control and where you applied nano urea. This is the same pictorial view of the experiment where we are applying nano fertilizers since 2010. Then some produce we have developed. Recently, this is our recent product. We are undergoing to develop and validation nano nitrogen, nano potassium, and nano phosphorus. And we are developed these we are trying to develop, and it is not exact what we are developed. We are trying to develop these three nano nitrogen from biological sources, nano P from biological sources, and nano K from biological sources. This is the view of my lab, and we are almost under study the impact of these three formulation in currently 2025-26, how these formulation impact the wheat growth and yield. And very soon we will find the result, and then we can be able to discuss the implication of biological source of nanomaterials and the impact of wheat. But these three materials are developed in our own lab. And this is some picture in my own lab. Our Vice Chancellor is visiting along with the Dean and Head of the Department. Dr. Alak is visiting our field experiment. IFCO persons are visiting. Some industry people from Tata, from SAIL and Jindal, they are also visited to our field. So I think this is some visitor is also in my field, and the farmers who is regularly visit to our field. And I personally thanks to our farmer which always visit to our field, and thanks for one and all for patience listening to me. Thank you. Thank you very much. If any query, question, you are most welcome.
Thank you, sir. Now, if anyone has any doubt or question regarding nanofertilizers, he or she may kindly post them in the chat box. Dr. Kumar will address and answer the queries one by one.
चैट बॉक्स किधर से आएगा? इधर से
सर नीचे है ऑप्शन चैट बॉक्स, चैट लिखा हुआ है.
अभी तक तो कोई आया नहीं है मैडम.
सर वी विल वेट फॉर 1 or 2 minutes.
आप डायरेक्टली भी पूछ सकते हैं. All work is my own lab. So,
Sir, Dr. Varsha
yeah,
has question. Organic urea is produced.
pardon?
Organic urea is produced in lab.
What it means? Dr. Barsa, what you want to ask? Organic urea? Urea is always organic. So, what you want to say? Nano nitrogen from the organic sources can be produced in the lab. For example, uh, some legumes leaves are having more amount. For example, more amount of nitrogen. You extract that nitrogen and convert into the nano form. That would be the organic sources of nano nitrogen. But urea is always organic, not considered for organic farming, but structure is organic. One by one.
Sir, next question is,
हाँ,
are
आई एम जस्ट
nano
कमिंग। बहुत तेजी से आ रहा मैम, तो एक एक छूट जा रहा। मैं वन बाय वन आता हूँ, नाम से बुलाता हूँ।
yes,
एक्चुअली में ऑर्गेनिक सर, नैनो यूरिया का डिसएडवांटेज क्या है? सोनू जी, नैनो यूरिया का सबसे बड़ा डिसएडवांटेज है कि ये हाई एंड प्रोडक्ट है, तो बहुत ही प्रिकॉशन से इसको आपको यूज करना पड़ेगा, और सम टाइम अगर आप गलती करते हैं तो आपको इल्ड पेनाल्टी हो जाती है। और बाकी नैनो यूरिया का ऐसा कोई डिसएडवांटेज हमें नहीं लगा अभी तक। ऐसा कुछ लिटरेचर में आप मिलेगा कि सॉइल हेल्थ को हैम्पर करता है। और एक और डिसएडवांटेज नॉट नैनो यूरिया कॉमन है कि यू नीड टू टेक केयर ऑफ योर आईज एंड योर हैंड व्हाइल अप्लाई द नैनो यूरिया इन द फील्ड। इसके बाद है फतेह सिंह, how nano fertilizer are prepared or developed and why not used in the modern agriculture? तो फतेह जी, ये नैनो फर्टिलाइजर आर prepared by two way. One, top down approach, and second is bottom up approach. There are several other sub types to prepare the nano fertilizers. And in modern agriculture, because this is the very less time to entering in our agriculture system, 2021 nano area was prepared and entered in the Indian agriculture scenario. So hardly 4 or 5 years has passed, and it infiltrate across all the agriculture system, but it will take time to get full bloom. So it is using in the modern agriculture, and they have one most important things. Once you are going to apply nano urea, your signing of the fruit is good. So modern agriculture, the objective, if your objective is signed fruit, then you can go for nano urea. Good evening, sir. DS. My question, can nano urea replace the conventional urea? No, never. Because nano urea is a foliage applied material, and foliage can only be obtained with the application of conventional urea. So nano urea not fully replace the conventional urea, but up to some extent, it might be some cases 25%, it might be some cases 50% can replace urea, conventional urea with nano urea. Now, Sayar, our nano fertilizer is effective to prevention of definitely. A nano fertilizer is very like meager amount, 20 gram per hectare, 22 gram per hectare. If it is not utilized by the crop, it would be utilized by the microbes. So there is no chance of eutrophication in case of nano fertilizer. Not eutrophication, any kind of pollution in water, environment, or human. In this respect, Dr. Barsa, thank you. Nanotechnology, डीबी नैनो टेक्नोलॉजी क्या पूछना चाह रहे हैं, नहीं क्लियर है? How you spell misconception of nano fertilizers? So I'm not getting what you want to exactly know. Misconceptions means nano fertilizer is not working, is not working well. It might be some positive or negative impact, but definitely it is impact. It have impact on crop growth and yield. So misconception is there, nano fertilizer is not working or it hamper the soil fertility. So as per my personal opinion, it is not going to hamper. It might be due to where I am working. This is the Pannagar condition. It are having high amount of organic matter, which is supply the nutrient to the crop under low nutrient application rate. But as per my opinion, it is a misconception. Good evening, sir. I want to know the role of nanoparticles like nanogypsum on saline soil as I am working on the microbes assisted phytoremediation on saline soil will be useful for us. Definitely, I have not any experience on saline soil, but definitely it will work, and especially in case of quantity. 6 to 7 ton per hectare gypsum are required to rectify the reclaim the saline soil. You can reclaim your saline soil by my first. If you think about my previous soil, first slide, where the concept how nano gypsum can be compensate for 6 to 7 ton of normal gypsum for claiming the saline soil, but I am not a man of saline soil. It is a hypothetical experiment you can do. Next. क्या ये माइक्रो ऑर्गेनिज्म को हार्मफुल नहीं? सोनू, it provides a strength to my, as per my experimental result application of खासकर I am talking about nanochitosan. It provides to the strength of microorganism if microorganism is facing abiotic stress, especially moisture stress. So nanoparticle like nanochitosan, my own work, they provide the strength to the microbes, but it is not sure about other nanoparticles or nanomaterials, which like silver nanoparticle, it kills the microorganism. Now gold nanoparticle kill the microorganism, zinc nanoparticle kill the microorganism, but some microorganism may be helpful to some nanoparticle may be helpful to microorganism, some nanoparticle may be harmful to microorganism. The next effect of nanourea or nano DAP on soil structure like a compactness. There is, I think I have no any idea about this, but I think there is no such kind of impact of nano DAP or nanourea on soil compactness. I have no any research data on this, but my opinion is that there is no impact on the soil compactness or any soil structure phenomena. Discuss the advantage, limitation, and future prospect of nanourea in Indian agriculture. This is a very important question. As you know that we are importing urea 20%. We are major consumption. We are major consumer of major consumer of nitrogen. Are importing the urea from the importing the urea. And one more important thing, if you are not importing the urea, if you are manufacturing the urea, the energy which is required for the manufacturing in urea is also importing. So, and government bear a high amount of subsidy on the urea production. For example, what the bag you are getting is around 265 rupees per 45 kg, and the actual cost of that bag is around 4,000 rupees. So government is bearing remaining cost and heavy subsidy burden on the urea. So either today or tomorrow or day after tomorrow, government is going to withdraw the subsidy, and that will cost to the farmer. And in such cases, nano area will be boom at least nitrogen would be available to the farmer. Then limitation is that there is really this is very early stage for the say anything, but limitation is that it require more and more research and studies, especially of scheduling of nanourea, when to apply, how to apply, and how much apply. That would be get definitely a good impact on the crop production, and this is the limitation. Then future prospect, if government withhold the subsidy, nanourea would be a boom. So nanourea have a good future, and they either today or tomorrow or day after tomorrow, government would uphold the subsidy. Then KMS, continuous use of nanofertilizer is safe for soil. What about the residual impacts? So nanofertilizers, it depends on the kind of nanofertilizer. But if you're talking about nano urea or nano DAP or nano potassium, in 15 year of the study, I didn't find any negative impact on the soil. And if anybody want to visit, they are most welcome to visit Pannagar. I will show you in the field. So as per my opinion, nanourea have not any negative impact of soil health, but I am still studying that in the scientific data. So I think any other question? Any other question? Any other query?
Maybe, sir, all queries are solved. We will share your email with participants for future queries if you are comfortable with that.
Yeah, definitely you can share my phone number, my mail, anything you can share. No issue.
Okay, sir. Thank you. Thank you so much. Thank you so much, Dr. Rajiv Kumar, for joining the Plan 2025 International Training Program as an eminent speaker. His enlightening lecture on nanotechnology applications in agriculture was very informative and inspiring. Dr. Kumar's deep insights into innovative nanotechnological interventions, improved nutrient delivery system, enhanced crop activity, and sustainable farming practice have greatly enriched the knowledge of all participants. The clarity with which he explained complex concepts and their practical applications made the session truly valuable and engaging. We are grateful for his time, expertise, and willingness to share such advanced knowledge with us. His contribution has significantly added to the academic and practical strength of the program. Once again, we thank you, Dr. Rajiv Kumar, for your valuable guidance and for making the session a memorable learning experience. Now, looking forward, I also warmly welcome and thank you, each one of you, to this week of learning, collaboration, and innovation. May Plant 2025 sow the seeds of knowledge, nurture the spirit of entrepreneurship, and harvest the fruits of sustainable growth for generations to come. Now, it's time to extend my sincerely special thanks to Professor Gurpreet Singh, CEO and founder of AgriWorks Green, for taking the initiative to organize this event. I also express my sincere gratitude to our Dr. Rajinder Venibal, Dr. Harvansh Singh Barania, Dr. Gushmander Singh, Lavjit Singh, Gurdeep Singh, and Arshdeep Singh for their valuable support and contribution. Let's make the event successful by joining the hands together. Once again, thanks to all of you for being a part of Plant 2025, and thank you for your patience, trust, and precious time. And thank you to be with us today. Once again, thank you. Thank you so much, everyone. Thank you.
Welcome.
Thank you, sir.
Thank you, Dr. Gurpreet.
Thank you, sir. Thank you, everyone. Thank you.